broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, welcome to part one of the Christie Terra webinar that we're doing for our North American friends. My name is Nick Wheeler, and I'm joined today by, quite a large amount of colleagues. I've got Tom Bocker with me, he's my wingman, Peter Kaiser, Joel Terensky, and Jason Wines. So I hope you're going to enjoy this. This is part one of a three-part series. You're going to be a little bit of info on the webinar. You'll be able to ask questions using the question tool that's available on GoToWebinar. And at the end of the webinar, we'll be answering questions that have popped up several times and so on, just so that the ones that sort of get the most interest. But nevertheless, if you do ask a question, then we will answer it either during the webinar or at the end or even afterwards. So all the questions do get answered. So let's start. So Christie, so the Terra part one, this particular webinar, I'm going to be going over what the what SDVoE stands for, what the Alliance is. I'll be going through like a product introduction on Terra and finishing up with a case study for Zurich Opera House, and then we'll go into questions. Part two, which is tomorrow, same time tomorrow, we'll go a little bit further into depth into Terra and what the Rx and the Tx are. So in terms of language, an Rx is a receiver. So when I say Rx, I actually mean a Terra receiver, and a Tx is a Terra transmitter. We're going a little bit further, kind of in depth into networking, cable considerations, and different case studies in a satellite control center, which we did in France, and again questions. Part three, which is going to be on Wednesday next week, Wednesday 20th, I believe, is going to be purely on the manager, so that we're going to show you how the manager works with a live demonstration and go through different modes and settings and so on. So that's going to be next week at the same time, next Wednesday 20th at the same time. So let's get into the nitty and gritty. So SDVoE stands for Software Defined Video over Ethernet. And so the idea of the Alliance is to try and standardize a means of sending AV over IP, over Ethernet, okay? And to create like a common platform that allows the different members to develop software solutions sort of based on this hardware platform. And so one of the advantages of having an alliance like this is that it standardizes everything, and so SDVoE devices all of a sudden become interoperable. So if you have products of different SDVoE vendors, and they can talk together, and that's pretty important. The founding members, there are 6 of them. Christie is a founding member. These 6 companies are actually part of the board of the Alliance, and we sort of define where the technology is going and what we'll be able to do with it. Netgear is also a founding member, and they've been very active on in the market, and we'll be going a little bit more into the networking side tomorrow. But they've come up with some pretty neat solutions as well to help us with the sort of backbone between the TX and the RX. Other contributors, other companies that are contributors, and including the latest ones, which are earlier on this year, Lightware and Analog Way, and there are also adopters as well. So there are like 40 different companies now that are part of this alliance, that are embracing alliance and developing products. The difference really between an adopter and a contributor is pretty much down to marketing. The sort of the base technology is available to everyone. Going into the specifications, the biggest one is really zero latency. So what we're aiming to do is to transmit video over Ethernet with zero latency, or pretty much 100 microseconds in genlock mode. And for those that are interested, 100 microseconds is 0.0001 seconds. So it's less than a thousandth of a millisecond. It's like a 10,000th of a millisecond. And to do that, so there's no compression per se, there's no decompression, as it were, because that takes time. A comprehensive API to be able to control what you're doing with the different types of signal. When you're sending them over the network. It's uncompressed transport for all resolutions from HD right up to 4K 30 signals. So there's no compression at all. It's literally transmission. And it's artifact-free transmission of 4K 60, so it's indistinguishable from the original source. And the only thing, so obviously we need to compress it a little bit, but instead of compressing the whole signal, it's only certain pixels that get compressed. So it's mathematically identical between the transmission and the reception. It also includes multi-channel audio transmission and independent routing, so you can route analog audio or embedded audio over HDMI to different destinations, and it doesn't have to follow the video. And the same thing goes for RS-232 and infrared transmission that can be sent to different destinations. There's also like a gigabit Ethernet network that sort of piggybacks on all of this, and I'll be going into a few examples. A couple of examples of what you can do with that later on in the presentation. I talked about interoperability between vendors. So the API, the read sync clock, and the setup management between SDVoE devices is identical to all vendors. So you're not locked into a single vendor when you're sort of going into SDVoE, which is the case for some of our competitors. We also do broadcast quality upscaling and downscaling with aspect management and frame rate conversion, so on, and those and display wall processing with bezel compensation and microsecond sync, so you can take a single source and spread it across a video wall without having sync issues between the different elements of the video wall. And multi-channel audio down mixing to stereo as well. So you can down mix HDMI audio, HDMI to stereo on the receiver end and output it to whatever you want to. Those last three really are specific, a little specific to Terra. It's like the software part of the technology. Everything above that is pretty much available to everyone. It's part of the basic hardware set. Talking about latency latency I just wanted to give you a few examples of what latency is with the different systems that are available. So you can see with things like JPEG 2000, you've got between 30 and 150 milliseconds of latency. Again, because it compresses the whole signal and it on the encoder end, and then it gets sent across the network and then gets decoded at the other end, and that takes time. H.264, which is widely used, takes anything between 100 and 1,000 milliseconds. So the aim of SDVoE is really to keep that latency as low as possible and keep the quality as high as possible. So that's really what this is all about. So SDV is really the first sort of network-based system that really can be used for zero latency audiovisual transport and distribution of uncompressed, 4K 444, and the pixel pipeline compression, which is what I talked about earlier on for 4K 60, permits us to transmit that signal, in a mathematically lossless form. And together with the USB and the RS-232 and the infrared and audio switching and distribution, which can be completely independent from one another, and the signal processing that's available right now, including scaling and the multi-viewer and the video wall, which we'll be going into between today and today's presentation and tomorrow's presentation, you end up with a tool that's incredibly powerful. So it really is the foundation for the decentralized sort of network-based matrix switching system and video processing system. So going into Christie Terra. So Christie Terra is Christie's first SDVoE-based product. It is an AV signal distribution control and processing system that has a KVM platform that operates on a 10 gig network. It's based on SDVoE, so it's uncompressed AV transport. It's incredibly flexible and scalable. There are actually three elements to this product: the transmitter, the receiver, and the controller. Its functionalities is, obviously switching, which I've talked about quite a lot about already, extension, KVM and control, video walls as well, the multi-viewer function of the RX receiver, and source and destination match, where the transmitter and receiver in Genlock mode, and whatever comes into the transmitter actually comes out. That exact same format comes out of the receiver. So this is what a Terra transmitter looks like. It has two video inputs, DisplayPort 1.2 and HDMI 2.0. That's next is the FFP transceiver, and that's what connects it to the 10 gig network, either using fiber or copper cables. A gigabyte Ethernet connector for that Ethernet gigabyte network sort of piggybacks on everything. That can be incredibly useful, and actually does get used quite extensively for control as well. Not control of Terra itself, but control of other devices that are connected to the system. This is USB 2.0. It's bi-directional, and that's used for that can be used for KVM. It can be used for hard drives, USB hard drives, and so on. And you can set that up in very different ways, and we'll be going into that in the different ways you can set that up in part 3 next week. External power supply, RS-232, that can be routed separately as well for control. Infrared in and out as well. Analog stereo audio, which can be bi-directional. So that's on the back of the unit, and on the front of the unit, there are signal and system indicator lights that tells you if it's live on the network, if the USB is connected to it, if it sees a video signal, or if it's if there's the Ethernet connectors being used, and so on. There are two buttons on the front. One can be used to select a source, so you can switch between DisplayPort and HDMI on the input side. The other one is not being used at the moment; is reserved for future use. And on the receiver end, you pretty much got the same thing. The only difference between the transmitter and receiver are the video connectors. So there's a single HDMI output, and the USB connector is a little different, but you've got exactly the same thing. So you've still got the SFP transceiver there, which connects to the 10 gig network. You've still got Ethernet and RS-232. The button on the front of the receiver, however, actually copies and shares the EDID of the device that is connected to the HDMI output. You want to be careful when you're using that, because it actually broadcasts it over the network. But we'll be going into sort of EDID management and how you can do this, that kind of thing, in part 3, when the webinar that's going to be on the Terra software manager. The third sort of physical element of this is the controller, and it's pretty much the heart of the system. So the controllers run using the Terra Manager software. It communicates with all the transmitters and receivers and all the SDVoE devices that it on the network. So it actually connects to the switch. It sort of auto configures the transmitters and the receivers in terms of IP. It holds the system configuration. It manages the device updates and swaps. So if you need to swap out a TX or an RX, the controller will be able to do that seamlessly without you having to go back in and redo the layouts or presets, as it were. We call them layouts when you do that. So very useful feature there. The EDIM manager's on there. It stores layouts for recall. You can control it using an API, not necessarily the manager software. You can also have a backup controller as well for redundancy, and it also has like a little web server there, so you can have an XY panel that looks just like the front panel of a matrix switch, where you have inputs, which are the transmitters, and outputs, which are the receivers, and you can use that just as you would a standard matrix switcher, but choosing what you want to switch. So you can choose individual, video, either DisplayPort or HDMI, or audio and USB and so on, RS-232, and route them, wherever you want. There are other SDVoE products that we have as well. One of them is the TSIC card, which we use for a number of our projectors. It's an SDVoE input card. So this connects. So you've only got a single a single like fiber connector on the front there, LC-LC. But you still get everything else. You can still control the controller. The projector, from a laptop and log into its web page to be able to control it and so on. And there's also the same thing for the Christie E1100 LED controller for microtiles LED that also has an SFP Plus connector and so on. So you can connect those directly. You don't need a receiver to be able to do that. You've got to connect to those projectors and microtiles LED. So we have a complete ecosystem around the SDVoE, where you can have transmitters with connected to devices, to media players or cameras and so on, or other SDVoE Alliance devices. And you can have receivers connected to legacy displays, or have the switch connected directly to the TSIC card or whatever. And all of that becomes like an ecosystem. And the 10 gig switch in the center pretty much becomes a matrix switcher. That's really what you need to look at that as being right now. It's just one big matrix switcher that can pretty much be any size you like. In terms of control, what I'm showing here is obviously there's the controller there, but there's also Widget Designer, which you can also run, which has its own, which has the like a plugin for Terra, and you'll see all the commands, the API commands are listed there, so it becomes very, very easy to design your own interface using Widget Designer. So some of the functionalities I've already talked about. So system-wide EDID management, where you can actually go and pick the EDID from a specific transmitter and send that to one or more. You can actually pick it's on a receiver end. So you pick the EDID from a receiver. You can send that to one or more transmitters on the network. We have HDCP 2.2 support. We also support HDR and deep color in Genlock mode. I talked about Widget Designer, the Widget Designer module, and the JSON API. And there's also a question module that's available if you want to use that. The content is encrypted, across the network. So not only can it can be fiber, which is secure, but it's also encrypted. So it's mathematically lossless processing. It's artifact free. I've already gone through RS-232 and infrared and serial and the gigabyte signals that can be used to interface control across the system between the various devices that are connected to the TX and the RX. The control is also secure, so it's encrypted, and we've got event logging and obviously the backup controller feature, where the backup controller will actually sort of kick in if it doesn't receive like a ping or a return from the main controller after a certain amount of time. So going through the applications for Terra, the basic application of this is an extension. Okay, so you can actually use a transmitter and a receiver without connecting it to a network, just by connecting them together using, LCLC fiber or whatever, using the SFP plus connectors. EDID management is push button simple. You push the button on the receiver end, and it sends the EDID to the transmitter, makes it available to the device that's connected to the HDMI or the DisplayPort input. But also transport, audio and USB and gigabit Ethernet. So that second example there shows you how you can use the Ethernet, for example, Ethernet cable connectors on the transmitter and receiver. And what this illustrates is that you've got the DisplayPort output from the Coolux, the Coolux media server, Pandora's box media server, sorry, connected to the transmitter. You've got the HDMI output connected to the projector, and you can take a laptop and connect it to the Ethernet, the RJ45 connector on the transmitter, and access the web page on the projector, so long as the projector is connected to the receiver using an Ethernet connector as well. And I'll talk more about that in the case study at the end of the presentation. The next one, which is probably the most important one right now, is switching. So in its switching mode, in switching application, it's highly scalable. So the limit really is it's the size of your network. It's the number of ports that you have available. And you can stack switches together to make it as big as you like. There's pretty much no limit to the number of devices, SDVoE devices that you can have on the network. It does format conversion between the transmitter and the receiver, so you can tell the receiver to output a specific resolution, and the receiver will scale the signal from the transmitter to whatever output resolution you've set it at. You've got breakaway audio control, so the audio, when you route the video signal from a transmitter to a receiver, you can take that audio and route it somewhere else to a different destination. And you can do that with control as well, with RS-232 and USB. So I'm going to talk about cost-effective switching. That 10 gig network switch that's in the center there actually replaces DisplayPort router, an HDMI router, a USB router, an RS-232 router, and so on. So everything gets, can be replaced by a single 10 gig Ethernet switch. And because it's network technology, you can expand it over time. So this can start as small as you like and get as big as you like over time with no problem at all. there's, again, there's no limit. When you have a 32 in, 32 out, HDMI matrix switcher, once you fill those inputs and outputs up, then you're stuck. If you do the same thing with SDVoE over a network, then all you do is just add a switch to your design, to your installation, and you're adding more ports. And the ports can be inputs or outputs, and they can change as well. They don't necessarily need to stay, inputs or outputs. So the whole thing is scalable and modular. You can change things around very, very easily. A port is pretty dumb, as it were. So it can be whatever you want it to be at any one time. So it's incredibly flexible. Video walls is another one that's gets used a lot of the time in our installs. So it's not the transmitters, the receivers upscale, not the transmitters on this. So here, what the receivers are doing is taking the video signal from the transmitter and spreading it across multiple screens. So each receiver subscribes to the same transmitter, and what it's doing, it upscales to and displays the part of the signal that it's told to by the controller. And it's broadcast quality scaling, and you can change what you're seeing just by simply recording a layout. So that video wall can change from being a video wall with a source spread right across it to something completely different just by recording layout or using third-party API. The multi-viewer is something that's incredibly useful as well. So here, a single receiver will subscribe to multiple transmitters at the same time and display thumbnails, as it were, of those sources on the screen. So again, the receiver can be any resolution you like. We'll be going more into the multi-viewer and how you can use that in tomorrow's presentation. But there's, I think it's like 30, from memory, I think it's like 36 is the maximum, or 34 or 36 is the maximum that you can, maximum number of thumbnails that you can display on the screen. So they can be really, really small. So you wouldn't see much. But yeah, I think it's 30, 34 or 36 transmitters that can be subscribed to by the receiver. Controlling KVM. So this actually is really interesting. And I'll be talking about this particular application in tomorrow's webinar at the end in the case study for the Orange Satellite Control Room. So basically what we have here is an AV switch, AV router and a USB router at the same time. And what we are able to do is to route the HDMI and the USB from any transmitter to any receiver, pretty much. So anyone on the right-hand side, any receiver would be able to take control of any of the transmitters. And the USB can be used for many types of devices. And one of the nice things is you can actually use the USB with like a hub on the receiver end, and use it for not only KVM but have hard drives and stuff like that, thumb drives that you can use because the full bandwidth is available. And because the latency is so low, it actually works very, very well indeed. So when you're on the receiver end and you're controlling a PC that may be in a rack that could be in a completely different building, it's as if you're at it's so fast, it's like working with a PC on your desk. It's very, very effective. And you can do all this at once at the same time. So we talked about the ecosystem earlier on. Well, you can apply all of those different applications to your ecosystem. and change things around at any one time. So a touch screen can display a single source, or it become a multi-viewer, and the multi-viewer can become a single source, and so on. So the receivers can change the mode that they're working in at any time. So it makes it incredibly flexible, and you can have all of that at the same time, and add to it, as your system evolves. You can add, different types of devices to it. You can you can mix, copper and fiber depending on, how far the different transmitters and receivers are from the switch. So you've pretty much got everything, all those applications and functions within the same ecosystem. So the manager software, we're going to go really into depth on manager software on Wednesday of next week. It's extremely user-friendly. It really is easy to use. It's like, to learn how to use it, it's like, I don't know, 2 hours, and you can use it. Most of it's drag and drop. It interfaces with a Terra controller. The controller actually goes out and finds all the SDV devices on the network, and you use the manager software to set up the IP address, and you can update the firmware on the devices, and it's sort of semi-automatic, because the only thing that you need to do is to select or tick the devices that you want to update, and you can use it to name each device to make it easier to manage on a day-to-day basis and use, for the user. You can manage the audio and RS-232 and USB, so you can limit what users can do with the USB and the way that audio is being sent over the network. I've talked about the Terra Manager and layouts, but it also has reset functions. So if you need to reset a device, you can do that. You can reset the whole system if you want to. You can configure the backup controller using the software, and you can also create configuration backup files. So this is pretty much so you can, although you can use this as a user on a day-to-day basis, and there are 2 types of user, like administrator type user and a user type user. If you connect to if you use the software manager as a user and connect to the controller, then you'll only get I think it's a single page, just the operations side. So it's pretty much used as admin, and it really is admin made easy, and you'll be able to see how easy it is on Wednesday of next week, part 3. So I'm just going to show you a couple of shots of this. So this is the configuration page, and there are like 3 display arrays that are created there. I'm not sure if you can see much there because the screen may be a little bit small, but you can see there are like 6 different steps to set this up. And it's really very, very straightforward. So that's the configuration page. This is the operation mode. On the left-hand side, you see a list of transmitters that are available. And when you want to put something on a screen, you literally drag and drop a transmitter into, onto a screen or onto a receiver in a blue box there. Global settings. This is where you set up the what you want to do with the controller in terms of external control. You can give it a name, you can change its IP address, you can configure the backup controller. This is where also you manage the licenses for the different devices. So the more devices you have on the network, the bigger license you're required to be able to use those devices. And again, you can, as the system evolves and gets bigger, then you can change the device key on it to adapt. You can download the logs. You can restart the system. You can restart, sorry, the controller and shut it down. And there's also factory reset as well. And for those rental staging people out there, you can actually delete the system configuration completely. So what that does is just it deletes configuration, but it keeps all the IP addresses of the TX and the RX and the controller. So when you come back after a show, you can wipe the system completely clean and get it ready for the next show. So I'm going to go into the case study right now. I'm going to talk about Zurich Opera, which was the first installation we did in Europe, the first Terra installation. This is a photo of the Opera House in Zurich in Switzerland. So the first thing I'm going to talk about is the requirements. You can see the photo there of what they wanted to do. So they had a new stage production that required 4K content and 4K projection. And but most of all, they needed live camera inputs that had to be displayed on screens of different sizes that were going to be hung in front of the balconies, staged left and right. But some of them were in portraits, some of them are in landscape. And because they were going to do this live, they needed something that had very low latency. They had an existing fiber infrastructure, so we had to be able to use that. It had to be easy to use for the technicians there. It had to be reliable because they pretty much work 24/7 or nearabouts. It had to be adaptable because they changed the shows and the content depending on the different shows that they have. And it had to also to be scalable so they could adapt it to the new productions as they come along. And so what they had up to that point was 3 4K projectors. I think it's 4 or 5 4 Pandora's box media servers. They had point-to-point fiber extension to various endpoints around the theater from the technical room where the Pandora's box media servers were at, but they didn't have any distributed control of those fiber links, so they couldn't switch things around very easily. So their challenge was to find the best solution to take the content from the media servers and live camera feeds onto multiple suspended screens each side of the balconies in-house. Again, some in portrait, some in landscape. And so they looked at different solutions, maybe suspending flat panels at different from the balconies in different ways, but that got too complicated, and then the wiring was difficult, and it ended up being really heavy and so on. And so what they ended up with is just suspending projection screens of different sizes. So they needed to be able to preview the content and the sources, so the content from the media servers and the cameras. They needed to be able to control the media servers and the projectors and the signal switching from a single point from the control room in-house. And they had to switch everything around twice a day. So they would rehearse. They would rehearse one show during the day, and about 4 p.m., 4 o'clock in the afternoon, they would tear that show down and build a show that they were actually going to do live that evening. And they do that day in, day out, practically every day. So they had to have a system that was flexible enough to be able to not only to be able to move around and change from like a projection or a screen standpoint, but also to be able to change the configurations of what the content was doing and what the whole switching system was doing, between rehearsals and the evening shows. And this is the solution that we came up with using Terra. And there are pretty much 3 different zones. So in the technical room, there was, we put in a Netgear M4300, a 96-port Netgear M4300 as the backbone of the whole system. And the nice thing about that particular switch is that it's SDVoE compatible from, by default. So it's out of the box. You just put it in the rack, connect everything up, and you don't have to. We don't actually go into that switch at all to configure anything. So everything that all the multicast and IGMP snooping and Querier and Fastleave and all that kind of stuff, all that's set up for SDVoE at the factory by default. So it's literally, that switch is literally plug and play. So in the technical room, we had all the transmitters coming from the quad servers, and also 2 receivers. No, actually, I think there were actually ended up being 4 receivers. There were 4 different cameras in-house. I've only illustrated 2 here. So 4 receivers as well, and the outputs from those receivers were connected to the HDMI inputs on the Pandora's Box quad servers. And so they were actually picking up the cameras that were in-house. So if we go into stage in-house now, there were 3 receivers, each for each of the projectors, the 4K projectors, and they've actually now switched to the TSIC card as well. So those projectors are now have the TSIC card installed. So those 3 receivers there for each of the projectors, and the receiver would follow the projector around whichever position it would be, either on stage or in-house. And also there were transmitters for the cameras. So the cameras are 1080p. That they had little SDI to HDMI converters. We used the HDMI input on the transmitters. That would go straight back over their existing fiber to the M4300, the 96-port Netgear switch, and then get routed to the RX that are in the tech room, so that the Pandora's Box could pick up the camera signals. In the control room, there was a smaller switch, again an M4300, but an 8x8. And this was used for control, so controlling Pandora's Box and Terra, and also the projectors. So you'll notice that each projector again has an Ethernet cable connected to the RX, and the guys there are able to go and log into the projector web page from the control room, with a laptop connected directly to that Netgear switch. So they can do things like bezel compensation and that kind of stuff, or parallax compensation, sorry. And also, turn the shutter on and off and stuff like that. And they also have like 2 monitors, again, that can change mode, either fast switch mode for looking at a particular source, or the multi-viewer mode when they wanted to look at the different cameras. And they were controlling everything from that single point. Between the 2 switches, they just had 2 10 gig links, 2 10 gig fiber links between the 2. That's all that was necessary. And again, we didn't actually go in and change anything on either of these switches. With just 2 links, it sort of worked itself out. We didn't have to go and create a specific and sort of aggregate the links between the two switches, because there are only 2. But literally out of the box, into the racks, connect everything up, and that was it. So extremely easy to deploy. From an implementation point of view, very straightforward. Connect the TX and the RX and the controller to the switch, power everything up, start the controller, and then the TX and the RX. And then we go into the the TSA. So there's a startup assistant where which you use to which goes and finds the controller, and in this particular instance there's also a backup controller. So the startup assistant will go and find both controllers. So you can give each controller its specific IP address, and then what it also does, and now this is part of the manager software, it'll go out and find all the TX and the RX that are on the network, and you can go in and assign IP addresses. Now, the system can do it by itself, so you can determine a range, a certain IP range, and then the Terra controller will go and give 2 IP addresses to each device, one for USB and the other one for everything else. And then, the next step is to configure, your arrays and create layouts. So configure the Terra system. In this particular installation, they wanted to use a slightly different IP range between the TX and the RX. So they wanted the TX to be in like 192.168, like 100, and the RX to be in an IP range that was 192.168.200, whatever. So we had to do that manually, but again, very easy using the Terra software manager. That's the only thing that was really time consuming. But apart from that, you can actually download a list of MAC addresses from the system, go in to and create an Excel sheet and create your IP tables, and then you can import that back into the system if you want to do that manually. So it can be, it really is very, very straightforward to set this up. But once you've done that, then you start creating your layouts and you start actually working with it. It's really straightforward. So it takes minutes to do that. This is a picture of the rack, and you can see the different TXs, and at the bottom there, the 2 controllers, master and backup. And in terms of cabling, so in the technical room, they're using fiber between the TX and the Netgear switch, and then they go fiber from the switch to everywhere else. That's a quick shot of the control room. So you can see the multi-viewer top right, and then the second RX actually showing the interface. You've actually got on the right-hand side the web GUI from one of the projectors, and behind it, a Pandora's box timeline. And on the left-hand side, you have the Terra Manager software. So that's as easy as it gets. So they've got everything. So one guy can literally handle the whole thing. And this was the result. I got a couple of pictures showing the results. So left and right in the balconies, there's a 4K projector each side, and there's one upstage behind that rear projection screen. And so you can see that some of the screens are portraits, some are landscape, and Pandora's box is actually taking the camera feeds and putting them into different layers. And that's really the reason for all this latency. So here's a different picture where you can see on the left, you can see the actor on stage, and you can see the camera feed behind it. So it literally had to be incredibly quick, no latency at all. Otherwise, it looked very, very strange indeed on screen. And it's been running now for a good couple of years. Yeah, I have to say that the technical director actually called us up and said thank you. So it's been completely, pretty much, yeah, actually 100% reliable from day one. So some of the projects in North America, that have been done. I'm actually going to invite my colleagues, my American colleagues, back into this conversation. They can maybe talk about some of the stuff that's been going on in North America. Tom and I are from Europe, so if Joel and Peter and want to sort of jump in.
Yeah.
And Jason too.
Yeah. So we're seeing applications with Terra, and it's related to the latency. It's related to the compressed video. So you see a list right there of a few of them. And I can speak to the municipality of Alaska. That one just went in about a month ago. Literally, they knocked this out in a day. They installed 12 receivers, and I think, or sorry, transmitters, 6 receivers, something like that. It's super simple to deploy, and absolutely loved it. And I think Jason knows a little bit more about the White House, maybe Stephen.
Yeah, I was involved in the installation at the White House. Again, a very clean installation. That is connected to a microtiles LED wall in one of the briefing rooms that you'll see on a lot of the news channels. We're also driving not only just that one, the new microtile LED wall, but also some flanking screens, and it essentially replaced the matrix switcher that they have in there. They still have the matrix switcher in. They haven't taken it out yet, but they're using that Terra system quite heavily. Yeah.
I'll add that a lot of our staging partners, some of our staging partners have also utilized the Terra in not necessarily controller switching mode, but also just for the transport, the basic transport mode, and getting that low latency and all the connectivity, all the KVM, and all those extra features help streamline a lot of stuff in those live event scenarios. We'll start to pick up, and it'll be really fun to see those come on. We also have a small piece of software called the device configurator that allows you to customize EDID functions, meaning individually make different changes on those devices in the absence of a controller for P and EDID as well. So we'll have another video or another webinar, probably a relatively short one.
Okay, well, any questions, guys, that have been?
Actually, Nick, I saw one question on here.
Yeah.
They were asking, somebody asked, oh, now my text is so small, I can't even see it. The spacing in the rack for the Zurich, they had a separate space. Was that for temperature and airflow?
No, not really.
Not really.
No, not really. They just had the rack space. So it just made it easier to put everything together. They could have taken the spacing out, no problem at all. But
yeah,
they had tons of space. So
ventilation is through the sides as well. So that and we also offer a rack shelf for those items where you can put 2 in a rack, and they're designed for that specifically. So
yeah. And there's also like a power supply thing as well, which is really cool. So we also have as an option. I think it's a power supply for up to 10 devices that connect to one of the standard, 19-inch rackable power supplies.
Yeah, and that's configurable too. I think it actually can. I thought at one point they said it could go up to 20, but yeah.
Yeah, it maybe could do. Yeah.
Yeah. There's a question in here about where's the drop off if you're not dealing with 4K content. If 4K content is not needed for the design, what do you think a comparable cost would be for a Terra system versus a normal matrix switcher, or say a 16 by 16 switcher. I'll just throw in my 2 cents on this one. 4K is just one of the features in this product that make it cost effective. It's everything else that you add into the KVM, the IR, the RS-232, all of that, and the 1 gig port over all of those things that eliminate the cost. So I'm not sure where the delta would be on that, where it would make sense to go to a switcher. If you don't need any of those other items, then I guess that would be your turning.
Yeah, but in terms of cost, it doesn't take many to make it cost effective.
Yeah,
I mean, it gets cost effective really, really quickly.
Yeah.
So even a 1616 is probably already pretty cost effective right there.
Yep, I agree.
Nick,
MSRP cost.
that's it.
Ah,
Nick, here's another one. Here's another
Yeah.
one. This is a good one. This is one I love. Can the controller control other SDVoE transceivers and receivers? And also, will other SDVoE controller control our transmitters and receivers?
okay. So SDVoE is interoperable. So the answer to that is yes, with a caveat. Okay. And so the controller will go out and find other vendors' SDVoE devices, but but it will be limited to what those devices will actually be able to do. Okay. So the Terra, the Christie Terra, the TX and the RX are pretty much full featured. So you've got RS-232 infrared and all those other things, and USB and so on, and audio and whatnot. A lot of the other stuff out there don't have all of those features. So yes, they will talk to each other, but you're going to be limited to what the device can actually do, right? So, but yes, it's interoperable.
Perfect. Let me just say, by the way, there have been a couple of questions going deeper into the details. So questions about the audio capabilities, questions about network using different subnets and stuff like that. So at this point, once again, I want to invite everybody listening and watching us right now to join the webinar tomorrow, as Nick will get deeper in this kind of stuff tomorrow. So please feel free to join the webinar tomorrow to get deeper into
we'll talk about we'll go into a little bit more of the networking without it getting too overcomplicated. So,
and the same link they registered for this one, they can access the other both tomorrow's as well as the 20th.
I think it is, but the phone I think the phone number's changed.
Okay.
As well between today and tomorrow, maybe. So you want to be aware of that.
All right. No, and
any other question?
No, and honestly, that there were not this many questions, but I guess one of the reasons is that you have been very, very clear in your presentation, giving this wonderful picture of thinking of Terra being a decentralized matrix switcher on base of a 10G network. For higher resolution video, audio, RS-232 infrared, KVM, USB, that can be routed freely, like a matrix switcher. This picture of a matrix switcher, including a video wall and multi-viewer processing that you will talk about tomorrow in more detail. So I think this picture is just this nice and clear that not a lot of questions are being raised in general.
I'll second that.
That's great. That's great. So yeah, I mean, it really is. It's not rocket science, okay? It's not. You don't have to be a mad IT guy to be able to use this. It's very easy to set up. It's very easy to use. And what we're doing is it's just taking a network appliance and using it in an AV way, to replace matrix switching. That's what we're doing with Terra. There's more coming, down the line in terms of products as time goes by. But But this is just the first step for Christie into this into the world of video over Ethernet, and it's an incredibly powerful tool. It really is. And the nice thing about it, and it pretty much sort of sums up really what it's all about. And this last slide here, SDVoE and Terra offers the same quality, the same latency as you get on a traditional matrix switcher, but you've got a whole load of more functionalities on that, with scaling and video wall mode and so on, and being able to route different types of signal to different destinations, but from the same point. So, compared to other systems out there that are available in the market, it is, we firmly believe it's going to be the future standard for video over Ethernet. It's a long way ahead of everything else out there. And the nice thing about it is that, it's easy to use and it's reliable. It really works well. Even our very first install, out of the box, plug and play, and it was done.
Nick.
So,
Nick.
Yes.
Another question.
Okay.
When you compare Terra to Phoenix, there are questions coming in comparing Terra and Phoenix. Is there anything Phoenix can do that Terra can't, and the other way around? Can you explain a little bit around that?
Yeah, not quite. So there's a little bit of overlap there. They don't quite do the same thing. Phoenix encodes and decodes, okay? And that's what it does really well. So it encodes in H.264 and it decodes in H.264. And that's how it publishes content on a network. Terra doesn't do that, okay? So Phoenix works on a gigabyte network. Terra works on a 10 gigabyte network. Terra doesn't decode or encode H.264. So there are use cases for both, really, and there's a little bit of overlap in some circumstances, in some control rooms, where you'd have maybe IP cameras and so on that would need to be decoded. Yeah, Phoenix is really good at that. Yeah, in terms of video processing right now, Phoenix is a little bit more flexible in terms of what you can do with the windows on the screen or on a video wall. But in terms of pure performance and especially the KVM feature, and I'll be talking more about that, on the case study tomorrow, which would typically have been a Phoenix installation. Terra is absolutely perfect fit. So there is a little bit of overlap. I think that'll change with time. I don't know, but yeah, that's pretty much it. So you've got H.264 encoding and decoding with Phoenix, and you've got the performance and uncompressed video on Terra. I hope that answers the question. And you're muted, Tom, I think.
Thanks for that. I think it should answer this question. And I'm looking forward to see this case study tomorrow. As you said, this would have been a Phoenix install, but Terra was the perfect fit for that. So at least tomorrow, we will see a little bit more of that. Let me get another question here. Do projectors share the IP with the RX, or can they be accessed on the network via TCP, UDP independently of the SDVoE system?
Yeah, that's a really good question. I didn't get into too much detail on that, but the IPs can be a completely different IP range from the TX and the RX. Okay, so the projectors in Zurich Opera are in a completely different range than the TX and the RX. So you actually do have like a gigabyte Ethernet network piggybacking on the SDVoE sort of system, as it were. So yeah, you can have completely different IPs for that kind of stuff. Absolutely.
So I guess that's it. What about you guys? Anything else?
No, I pretty much did it out of the park on that one, Nick. Yeah, I would just say tune in tomorrow. That sounds a little TV show like, but yeah.
Great. Well, anyway, thank you everyone for attending this webinar. Let us know if you've got any questions, comments, and stuff in the the questions tool that you've got, or if there's anything specific that you want us to talk about either tomorrow or next week concerning Terra or anything else. Drop us a line in the questions thing, and we'll look into it.
Yeah.
So in the meantime, I'd like to thank my 4 colleagues for bearing with me, and thank everyone for spending time with us today. Just gone over an hour and 5 minutes. That's pretty good going.
Yep.
And see you all tomorrow, same time.
Thanks for the introduction, Nick.
No problem.
Thank
See
you
you
all.
tomorrow, guys.
See you tomorrow
Thank you.
when we get deeper in we just get in some more questions, but we will answer them tomorrow. And the recording will be offline shortly. It will take us 1 or 2 days, and then it will be available for download on the comment channels, like the webinars before. Thank you, Nick. Thank you, Nick. Once again, it was a pleasure. It was a pleasure.
As always, my friend. Talk to you tomorrow. See you tomorrow.
Have a good day.